and that one over there. All right, so today we're going to cover section 6.3, which is called Logarithmic Functions and Their Graphs. I printed off the notes if you haven't grabbed a copy of them. You can come up and grab a copy. So this section, we are going to talk about what is a logarithmic function, what is their purpose, why do we need to use them. So in any algebra class, you'll always talk about logarithmic functions right after you talk about exponential functions, and that's because exponential functions and logarithmic functions are inverses. So y'all remember we learned about inverses not too long ago. So if you have an exponential function and you need to find its inverse, that inverse will always be a logarithmic function, and vice versa. So logarithmic functions arise from exponential functions that are too complicated for us to solve in our head. So for example, if we had an equation like this, say 3 to the x equals 9, we can easily see that the value that we need to plug in for x here to make this equation true would be 2. And remember how we learned how to solve this? We would rewrite 9 as like 3 squared, then you just set the exponents equal to each other. So that's an exponential equation, it's easy to solve. But then you have exponential equations like this one, 3 to the x equals 11, that are not easy to solve. We can't solve this in our head. And that is the whole purpose of logarithmic functions, is to help us solve equations like this. And the reason that they do that is because of this fact over here that exponential functions and logarithmic functions are inverses, means they can kind of like undo each other. All right, so let's learn about the definition of a logarithmic function. What is a logarithmic function? A logarithmic function has the form of y equals log base a of x. All right, so again, the way that I read that was log base a of x. Not log base a times x, log base a of x. That means we're plugging x into the logarithm. Now the full definition of a logarithmic function involves one extra part, and it starts off with this little double-sided arrow. And that double-sided arrow means is equivalent to. Equivalent to. So y equals log base a of x is equivalent to, or is the same as, x equals a to the y. So the equation on the left is called logarithmic form. So this is called logarithmic form. And the equation on the right is called exponential form. Those two equations are equivalent. That means we can interchange them. All right. I think there's one more thing I need to tell you. I told the other class the other day, so I'll mention it to you guys. There are a couple of restrictions on A. So there are a couple of restrictions on A. You won't have to to worry too much about these restrictions. They're not going to throw any like trick questions in here that deal with these restrictions. But a has to be a positive number, so a has to be greater than 0. And a is not allowed to be equal to 1. So a cannot be equal to 1. If you remember, these were the exact same restrictions that we had on a when we learned about exponential functions. Let me think if there's anything else. I think that's it. Now, this equation, or this definition here is what it's really called. This part here is very important. You'll need to have that written down on your index card. We'll use this so many times that you'll probably have it memorized. But this is super important for the rest of this chapter. Okay. So the first thing we're going to practice is just converting between logarithmic form and exponential form, and that's because whenever we go to start solving these, we're going to need to switch between these a lot. So you want to get comfortable with that. So it says use the definition of a logarithm to convert between exponential and logarithmic form. So I'm just going to write the definition of a logarithm up here. Y equals log base a of x is equivalent to x equals a to the y. So what you'll do is you'll look at these equations, you'll determine, is this in exponential form or is this in logarithmic form? Then you'll figure out what is x, what is a, what is y, and then switch them. All right, so we have g equals 4.5 to the 4th. This is definitely an exponential form. We see no logs anywhere. So I like to write up underneath here, x equals a to the y. Then you can kind of easily identify what is x, what is a, what is y. X would be capital G. A would be 4.5. Totally fine for a to be a decimal or a fraction. And y is 4. So then you just go over here, convert this to logarithmic form. Make sure you write a as the little base. So it should be like kind of in the subscript there. So that would be 4 equals log base 4.5 of g. That's it. So I know this kind of seems pointless right now, like what was the whole purpose of that, but this again is going to help us whenever we get to solving these equations. All right, the next one's definitely in logarithmic form. 5 equals log base 3.9 of t. So you can write the definition up under here. Y equals log base a of x is equivalent to x equals a to the y. Now you can identify what is y. What is y here? 5. What is the base a? 3.9, and x is t. All right, so we have t equals, base was 3.9, y we said it was 5. That's it. Okay. Try the next one on your own, or the next two on your own, see if you can convert those to the other form. 3 equals log base 8 of 512. I wanted to point out here, notice how I didn't put the parentheses around the 512 here. That's fine. You don't have to put the parentheses unless you have some kind of expression in here that's like 512 plus x or 512 minus x. But if you'd like to see the parentheses, you can put them around the 512. You may see one of these on the test. Let's see. Y is 3, A is 8, X is 5, 12. So y 12 equals 8 to the third power. So that would be exponential form. And then here, you got almost all variables. X equals A to the Y. So that would be Y equals log base 7 of X. Do I get that? Yeah. Being able to switch between these forms is really important. You want to be able to do it quickly. You don't want to waste a whole bunch of time doing this step whenever you get to solving the equations. So the more you practice these and the quicker that you're able to switch between these forms, it really does help you solve the equations when we get to section 6.5 next week. All right, so we have two types of special logarithms. These are the most frequently used logarithms. The common logarithm and the natural logarithm. These are the most frequently used logarithms. So they get their own special name and they get their own special button in the calculator. So I'm going to make a little table here to tell you about these two logarithms. We'll say name, base, and then symbol. All right, so we got the common log and the natural log. All right, so the common log has base 10. So instead of base A, we're going to write base 10. So this would be like y equals log base 10 of x. But again, this is used so frequently that it gets its own special symbol. And the symbol for the common log is just y equals log of x. So they just drop the base 10. So if you see a logarithm that has no base indicated, then you know that that's the common log and it's base 10. So if you see a logarithm with no base indicated, you know that's base 10. The natural log has base e. E is that irrational number e. It's approximately like 2.72. So that looks like this, y equals log base e of x. And its symbol is y equals ln. So y equals ln of x. Sometimes people think that says 1n, so that's actually an L. So ln like natural log, but backwards. So natural log. Typically, I will write it as a cursive L, so that you can tell it's not a 1. So this is usually how I write it. Just so you can tell that it's an L and not a 1. All right, so let's look at the calculator and find out where these buttons are. All right. So right here, if you're using the TI 83 or 84, the log button, the common log is right by the 7. Natural log is right by the 4. And I just found this out the other day. I didn't realize that we had this extra function. This is in the TI 84. I don't think it's in the TI 83. But if you go to math and you go way down, I think it's number 8, yeah, log base, that lets you plug in any base for any logarithm. So it lets you edit the base. And you can put in like a base 7, a base 1/2, anything. So before, like back when I was using the TI 83, you would have to use what's called the change of base formula, which I talk about in section 6.4, to evaluate logarithms with different bases. But if you have the TI 84, then you can use this button. So it's just math, and then you scroll way down. Yeah, there it is. Log base. Okay. All right, so we're just going to do a few easy examples where we're going to plug stuff into our calculator. So this says evaluating common and natural logs. So we're going to evaluate each of these logs, or each of these logarithmic expressions. We have log of 25. Again, if you prefer to see it with the parentheses around the 25, you can do that. There's no base indicated here, so we know it's a base 10 logarithm. So we're going to go to our calculator, do log of 25. Oops. Close parentheses. I think it's 3 decimal places on homework. So this would be 1.398. Sometimes I'll throw one of these on the test just for an easy question. What do y'all get for natural log of 3? 1.098. Okay, 1.098 or 0.99. And then our last one, it's not going like this. Oh, there we go. Oh, I put this one on here because it's on the homework. I wanted to make sure you knew how to type it in. This one says natural log of the 5th root of e squared. Okay, so natural log of the 5th root of e squared. If you have the TI 83, you're going to type this in a little bit differently than what I'm about to show you. So I'm going to type it in on the TI 84, and then I'll tell you how to type it in on the TI 83. All right, so we have natural log, then go to math. Then right here, option number 5 lets you do any index for a radical. So notice how on the TI 84 it puts this little box here. You can put in the base. That's different on the TI 83. Inside of the radical, our radicand is e squared, so that's second ln squared. Get out of the exponent, get out of the radical, close parentheses. If they want it as a fraction, of course, you could go to math and then frac. All right, so if you have the TI 83, here's what you're going to do. You're going to start the same way, do ln, or natural log of. Now you have to type the index first, so type 5, and then go to math, and then down here to option number 5, to where you can edit the index. And then type in your radicand. So the only difference is you have to hit the 5 button first before you go to that math menu. But you'll get the same answer. Okay. let's look at solving some equations. All right, so they call this solving elementary logarithmic equations. That just means these are the easier logarithmic equations. That's not to say that they aren't hard. Anytime it's your first time doing one of these problems, it can be tricky. There's no set steps that I can tell you to solve logarithmic equations, but I can give you some tips, and I will share with you some properties of logarithms that will help us to simplify these equations. All right, so here's my tips for solving logarithmic equations. Tip number 1 is to use the definition of a logarithm whenever possible, or when possible. And by the definition of a log, I'm talking about this definition here, y equals log base a of x is equivalent to x equals a to the y. So that is my number 1 piece of advice for these elementary logarithmic equations. Your book also includes this piece of advice. They say, try to make the argument of the logarithm, that's the stuff inside the parentheses. Try to make the argument of the logarithm of the stuff that's inside the parentheses match the base, if possible. And I'll tell you what they mean by that. So unlike exponential equations, there's no set steps for this. So you kind of just have to approach each problem individually. But this is my advice. Use the definition of a logarithm when you can, and try to make the argument of the logarithm match base. So what that means is like if you have something like log base 3 of 9, you could try to make this argument in here 9 match the base. You could rewrite it as log base 3 of 3 squared. So then the argument matches the base. And I'm about to tell you why that's useful with these 3 properties of logarithms over here. Three very useful properties of logarithms. All right, so the first property says that log base A, so regardless of what the base is, the base can be anything, log base A of 1 is always 0. That was a really good 0. I usually can't make them match up like that. All right, so log, regardless of the base, log base 2, log base 10, log base A of 1 is always 0. All right, the next one says log base A of A equals 1. So that means when the argument matches the base, they kind of cancel each other out. So when the argument in here, the part inside the parentheses matches the base, they cancel each other out. And then building off of that one, if you have log base A of A to some power, we'll call it X. Then again, the base cancels with the log, or excuse me, I said that backwards. The argument cancels with the base here, and you're just left with X. So whatever the exponent is. So that's why your book suggests trying to make your argument match your base, so that it'll cancel out. That tip is used less often than that first tip that I told you. All right, let's solve these equations. And I'll tell you which ones that you can expect to see on the test. All right, starting off with the easy one. It looks kind of complicated, but this is going to be an easy one. It says solve the equation, write your answer as a fraction in lowest terms. All right, so log base 128 of x equals 5/7. This is an easy problem because whenever they give you the equation in logarithmic form, super simple, all you have to do is just use the definition of a logarithm, convert it over to exponential form, and then finish solving it. Now this is going to help us because we already know rules about exponential equations. We know how to solve them. So we can see here that A is 128, X is just X, and Y is 5/7. So now we'll plug those into our exponential form over there. So that gives us X equals A to the Y, that would be 128 to the 5/7. And now we can plug that in to our calculator. All right, so 128 to the 5/7. If you have the TI-83, make sure you put your exponent in parentheses. 128 raised to 5/7 is 32. So we got a whole number here. We don't have to worry about writing our answer as a fraction. I should have put like write your answer as a fraction in lowest terms if necessary. We said that that's 32. Now, when we get into section 6.5, we'll have to check our answers for these logarithmic equations. But for right now, we don't know enough about logarithms to check our answer. So for right now, you don't have to worry about checking your answer. I don't know what I did to the screen. Let me try that over here. Good Lord. Okay, there we go. All right, so we don't have to worry about checking our answer right now, but we will have to in section 6.5. All right, so the next one says 2 raised to the log base 4 of x equals 4. Now this is kind of, we look at it and we think, okay, this is a logarithmic equation. We see that it has a logarithm in it. But this is actually an exponential equation because we got a variable in the exponent. So this is an exponential equation, which is great because we have a bunch of rules for solving exponential equations. And we know that to solve an exponential equation, the first step is to isolate the exponential expression. It's already isolated, it's here by itself. Then we try to make both sides have the same base, which is going to be easy here because we can just rewrite 4 as 2 squared. So go ahead and leave the left-hand side the same, but rewrite your right-hand side as 2 squared. All right, then we just set the exponents equal to each other. Log base 4 of x equals 2. And now we can do the same thing we did in the last one. So just use the definition of a logarithm to convert this over to exponential form. All right, so log base a of x equals y is equivalent to x equals a to the y. Let's see. A is 4, y is 2, and x is just x. So we have X equals, the base is 4, y is 2. That one's easy, we can simplify this in our head, x is just 16. Alright, so, like I said, this definition of a logarithm is super useful. You're going to have to use it a bunch, so make sure you have it written down on your index card unless you have it memorized. Alright, we got, I like this next one. This might be something that you see on the test, so we'll highlight that one. I also like part E as well. Alright, so this one says log base 9 of 2x minus 1 equals 2. This again is in logarithmic form, so all we have to do, write the definition of the logarithm, convert it over to exponential form, and then finish solving it. The only difference here from what we've been doing the last couple of examples is that now instead of having x is just the same as x, we have a little expression in there, but that's not going to change anything. See, a is 9, x this time is 2x minus 1, and y is 2. Okay, so we have 2x minus 1 equals 9 squared. So go ahead and simplify that 9 squared, that's 81. Then finish solving that, so add 1 and then divide by 2. So x is 41. So I like that one. I like that. You have to convert it over to exponential form and then kind of use some stuff that we've learned in past units about linear functions to finish solving that. All right, so I put this next one in here because it's actually super easy, but sometimes it throws people off when you see that ln. So we have natural log of e to the x equals 23.5. Now the trick here, and this is the trick for a lot of these logarithmic equations that involve ln, is to rewrite ln as log base e. So all we did, we'll write off to the side here, is rewrite ln as log base e. Now you can use those properties of logarithms that say when the argument matches the base, they cancel out. And you're just left with x. So you have x equals 23.5. And you're done. So that's almost always the first step. Or you can just remember that ln and e cancel each other out. But that's almost always the first step when you have a logarithmic equation that involves a natural log. Is to just rewrite it as log base e. Okay. We have one more. And I like this one too. I like this one for the test also, so we'll highlight it. We have natural log of 6x plus 14 equals 2. This one's kind of a mix of C and D. So again, the first step, we look at this, we see, okay, this is in logarithmic form. All we need to do is just rewrite ln as log base e. And then we can convert it over to exponential form using our definition of logarithm. Oh, and they want us to write our answer as a fraction here, so we're going to keep this, we're not going to plug anything into our calculator. We're going to just write this as a fraction. So I can see that the base A is E, that irrational number E. X is the expression 6x plus 14. Y is 2. So I have 6x plus 14 equals a to the y, so that's e squared. Now we gotta solve for x. Just pretend like that's another little variable or little expression over there. Don't worry about it, being e. Don't let that stress you out. Just subtract 14. Solve this like you normally would. That's e squared minus 14. Divide everything by 6. And you're done. X equals e squared minus 14 over 6. And if they allow you to plug this in the calculator, or if they want you to write as a decimal, then let's just plug that in real quick. Let me just show you how you would plug it in. If you have the TI-84, you have this little fraction button where you press alpha y equals, and it'll pull up this little fraction, and so that's alpha y equals. That'll pull up the little fraction button. If you have the TI-83, just make sure you put the numerator in parentheses. So you could do e squared, get out the exponent, minus 14 divided by 6. It's totally fine to get a negative answer. It's a negative 1.0, or excuse me, negative 1.102. So that I just wanted to show you that just in case they have an option for you to write your answer as a decimal. All right, let me stop the recording. Okay.